Okay, let's talk about states and changes of matter. First, let's talk about states of matter. And as we know, there are 3 states of matter. And our first state of matter is a solid. Now, a solid is when particles are closely packed together, also known as touching. And with a solid, they have a fixed shape and a fixed volume, meaning we cannot change the shape of a solid and we cannot change the volume of the solid. If we change the shape or the volume, we're changing the solid altogether into something new. Here is what the particle view of solids look like. As you can see, each particle, each ball is all close packed together. And here's what ice would look like molecularly in a particle view. Again, they're all really, really close together, practically touching. Our next state of matter is a liquid. And liquids are when particles are spaced out, but with small space in between each other. And for a liquid, they have an unfixed shape, but they have a fixed volume. You can change the shape of the liquid without changing it altogether. Like, you can take some lemonade from a pitcher and pour it all into a cup. Now we change the shape from a pitcher shape to a cup shape, but it's the same lemonade, but it's still the same amount of lemonade, just in different containers. That's why liquids have a fixed volume. And if you look at the particle view of a liquid, you see how there's kind of small space in between them. Those spaces help us manipulate the shape, but it's not spaced out enough to manipulate the amount of volume. And again, looking at what liquid water would look like molecularly, there's kind of small space in between, but not too much. And the last state of matter is gas. And a gas is when particles are spaced out, but with big space between each other. They're majority space. And because of that, they have an unfixed shape and an unfixed volume. We can change the shape and the volume of the gas, but we're not changing the gas altogether. And that's because, as you can see with our particle view and our particle view of steam, all of that space there, it helps us manipulate the shape and the volume. So with that being said, now that we know our 3 states of matter, there are 6 changes of matter. And matter can change from state to state without changing its identity. We see this when we're going from ice to liquid water to steam. Yes, we're going from a solid, liquid, and gas, but it's all still H2O. We just got H2O solid, H2O liquid, and H2O gas. And there are 6 ways matter can change. The first way is melting, changes from a solid to a liquid. Example, ice is melting. In the nice hot summer day, you're eating ice cream melts. Opposite of melting is freezing, changes from a liquid to a solid. That's how we make ice. We freeze liquid water to make ice. Our next change is evaporation. That changes from a liquid to a gas. So this happens when we're boiling water. We start seeing that smoke coming off, that steam. That's liquid H2O to gas H2O. That's also kind of the rain cycle as well. If it rains and the sidewalk is wet and over time the sidewalk becomes dry, yes, the sidewalk absorbs some of that liquid, but majority of that liquid evaporates into a gas, into our atmosphere, into the clouds to become rain later. And that reproducing rain is condensation, changes from a gas to a liquid. So those gas H2O particles from the evaporation of rain on the sidewalk becomes rain again later on. Also, if you're outside on a nice hot day and you have a nice glass of water, your glass on the outside starts to get wet. It starts to sweat. That liquid on the outside of the water is not from the water inside the cup. It's actually the gas particles in the atmosphere becoming a liquid onto your glass. Now, the next 2 state of phase changes of matter, you may not have heard about. And the first one is sublimation, changes from a liquid to a gas. So it skips that liquid phase completely. If you love ice cream, you go to the ice cream parlor, they open up that ice cream cooler and white smoke comes out of it. That's because those coolers are lined with dry ice. Dry ice is frozen carbon dioxide. When dry ice is exposed to room temperature, it instantly goes in the gas phase. That's why you start seeing it smoking. If you've seen on TikTok, people put dry ice in like a punch bowl for Halloween and make it smoke. That smoke is that gas. The reason why is because CO2's temperature at which it becomes a liquid, it's so small that it's irrelevant in real time. That's why it goes directly into a gas. And the opposite of sublimation is deposition, changes from a gas to a solid. Now, during a change of matter, there is a temperature change, which we know that when we're melting ice or we're boiling, we're decreasing the temperature. Oppositely, we would increase the temperature. So there is a temperature change in which heat causes the change by adding or removing energy. And all of this can be represented through a phase change diagram. So let's go ahead and look at what phase change diagrams look like. We have the melting point of water is 0 degrees Celsius. The boiling point of water is 100 degrees Celsius. So we're going to draw the phase change diagram for water. First, you need to label your y and x axis. Your y-axis is going to be temperature. Your x-axis is going to be time. Now you see how 0 is much lower than 100? 0 is going to go first on your y-axis. So go to put a dash somewhere in your y-axis and put 0. And label 0 as your melting point. This represents your melting point temperature. Now your boiling point is 100. And let's label that as your boiling point. Now for a phase change diagram, there's going to be 3 diagonal lines and 2 straight lines. We're going to do a diagonal all the way until it hits our melting point. And then we're going to do a straight line. Then we're going to do a diagonal line from our melting point to our boiling point, then a straight line, and then we're going to do our diagonal line again. Now, each of these diagonals and straights represent either a state of matter, solid, liquid, or gas, or a change of matter that we just talked about. Our 3 diagonal lines represent a state of matter. Our first diagonal line actually represents a solid. Second one is a liquid. Third one is a gas. Now these straight lines represent our change of matter. So going from a solid to a liquid, this first straight line, if we're going from a solid to a liquid, represents melting. And if we're going oppositely, we know opposite of melting is freezing. And if we're going from a liquid to a gas, that's evaporation. And opposite evaporation is condensation. Now we just learned about 6 phase changes of matter, changes of state, and that is deposition and sublimation, and we could just add that there. Now that we kind of know where our changes of matter, our states of matter are, we can start talking about energy. Now, as we're going left to right on our graph, we know the temperature is increasing. As temperature increases, energy is being added, and that's where the idea of heating comes into play. So when you're recording temperature, you're recording how fast particles are because it's being heated, because energy is being added. Now thinking oppositely, if we're going down the graph, energy is being removed because there's a cooling going on. So with all that in mind, as the temperature increases, the particle speed increases and are spaced out. And we can see that with our diagram of our solid, liquid, and gases. They're becoming more spaced out as we go up, as the temperature increases. And oppositely, as the temperature decreases, the particle speed decreases and are becoming closer together. So with that idea, let's go ahead and do the phase change diagram for ethanol. And we know the melting point is negative 114.5 and the boiling point 78.5. Again, labeling our X and Y axis, we have temperature and time. And remember, melting point is going to be a lot lower than boiling point, so we got to do our melting point first, then our boiling point, and just do our diagonals up until we hit our melting point, then a straight line, diagonal line until our boiling point, straight line, and then diagonal line again. And that is your phase change diagram. And that's it. Thanks, guys.